All right, so moving on with probability. I saved this for a separate day. It is still considered basic probability, but I wanted to kind of put these two specific things off on their own because although it's basic, it's a little more complex than flipping a coin or rolling a single die. Now, when I say basic, I'm calling this basic probability because there is this thing called compound probability, which we'll get into. But the idea that basic probability is you're doing one thing. You're rolling a die, you're pulling a marble from a bag, you're flicking a spinner in a board game. You're doing one thing and you're looking at the outcome. These two scenarios that we're going to look at today, you're still doing one thing. It's just that what you're dealing with is a much bigger set. Like if you think of, a deck of cards, if you've ever played rummy or poker or anything like that, there's a whole lot of outcomes in that deck of cards. If you roll a pair of die, if you're playing a game where you have to roll two dice, it's a lot bigger sample from your outcomes. Excuse me. So we're going to look at those two things specifically. So you won't have to worry about any of the other things that we talked about the first day, just this specifically with, a pair of dice and a deck of cards. So when you roll a single die, when you roll a single die, you have six outcomes, 1, 2, 3, 4, 5, 6. If you roll a second die and you're looking at the total of the two die, it doesn't increase. It doesn't double the number of outcomes. You don't have six outcomes, so you have 12 altogether. It's actually a multiplication problem. If you have six possibilities, I'm sorry this is so fuzzy, but it's the best kind of graphic I could find for it. So if we have two different dice, we've got one across the top, all the possible outcomes. We've got one down the side, all the possible outcomes there. You actually have 36 different potential outcomes when you roll a pair of dice. So if you guys have ever played Monopoly or I'm trying to think of another board game off the top of my head where you use two dice, and it always comes back to Monopoly. So, your first die, you roll a 1. Your second one, you roll a 1. So your total was 2. You just add them together. So you've got all these different possibilities. What you need to kind of get in your head is that rolling a 1 here and a 2 here, although may have the same outcome as a 2 here and a 1 here, you get 3s both places. It is different. Okay, what's physically on the dice is different, so we're going to count them as different outcomes. So I've got 36 different options here. So the types of questions that you're going to be asked are basically numeric. What's the probability you could roll a 5? What's the probability you could roll a 12? Things like that. But every single time on these, whoops, I just totally screwed that up. Every single time on these, your outcome, your total possible outcomes, your denominator is going to be 36. So what I want you guys to keep in mind is it's out of 36, whereas a single die was out of 6. So a little smaller version of the graphic here in a couple of questions. So the probability that you roll a pair of dice, what's the chances that you could roll a 7? Well, I'm going to count these guys up real quick. Excuse me. There's 1, 2, 3, 4, 5, 6 7s. So my probability of rolling a 7 is 6 out of 36, which I can reduce that down to 1/6. Please reduce your fractions. I'm not going to count them if you can't reduce them. All right, you guys are in high school, reduce a fraction. The probability of rolling an odd. So you go through and you count up all the different odd numbers. Literally, there's 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 odds. 18 out of 36, which reduces down to 1/2. Now, I kind of think that makes sense. Half the time you would get an odd, half the time you would get an even, because half of the numbers you deal with are odd, half of the numbers you deal with are even. Probability you can roll a 12. How many different ways can you get a 12? Well, 6 and 6 is the only way. So there is one successful outcome out of all 36. And then similarly, when you roll a 2, there's only one possibility out of 36 there as well. Okay. I will put this picture specifically in a separate document and attach it to your assignment so you can pull that up and look at it. So save you a little bit of time there. A deck of cards. Again, it's still basic. If you think like the old magician's trick, like you fan out a deck of cards and say, pick a card, any card. There's a lot of cards there. There's a lot of different possible outcomes, each one unique. If you're familiar with the deck of cards, great. If you're not, Again, I'll put this graphic out there for your assignment so you can literally look at it while you do the assignment to kind of help you out. There's 4 different suits: clubs, spades, hearts, diamonds. There's 2 different colors, black and red. These guys over here, the Jack, Queen, and King, are called face cards because they literally have a face on them. There's 3 in each suit, 4 suits. There's a total of 12. I realize I'm saying all this fast, but again, you've got the picture right there. So this just kind of an overview of the whole deck of cards as best I could come up with the different possible things I could ask you about. There's 4 suits. Those are the different shapes on it: heart, diamond, spade, club. 4 of each card. There's an ace of hearts, an ace of diamonds, an ace of clubs, an ace of spades. 2 colors. Each color has 2 suits, yada, yada. So again, a little bit smaller version of the graphic. I'll post this too. So if we look at that deck of cards and we're going to just reach in and pull out a card, it's all shuffled up and it's all mixed up. What's the possibility that I could reach in and draw a heart? Well, hearts right here. There are 13 hearts. Count them if you don't believe me. There are 52 cards altogether. So our probability is 13 out of 52, which will reduce. That will reduce down to 1/4. Now, I often think when you look at these reduced probabilities, they make sense. How many different suits are there? There's 4. How many suits are hearts? 1, 1/4. The probability you could draw an ace. All right, doesn't matter color, doesn't matter suit. There are 4 aces. There are 52 cards altogether. So I can draw a probability of 1 out of 13. Probability I could draw a face card. I already talked about that. These guys over here on the end are your faces. Right? That's a bad circle. There's a total of 12 of them out of 52. That will reduce down to 3 out of 13. Again, if you look at that probability, there's 3 face cards in every 13 cards of a suit. Last one is kind of an oddball, a red 3, specifically a red 3. Right? There's only 2 of those. 2 out of 52 reduces down to 1 out of 26. Okay, just check your fractions and make sure that they reduce. If you're not real good at reducing fractions, grab a calculator. It'll do it for you. If you need help doing that, ask me. I can walk you through it.